Building on reusable architecture patterns, you now focus on the moment when architecture stops being theory and becomes real, when something fails. Resilient enterprise architecture is not about building systems that never fail. It is about building systems that fail in controlled ways, recover predictably, and remain supportable under pressure. When leaders invest in resilience, they are investing in customer trust, service continuity, regulatory confidence, and the organization's ability to keep operating during disruption. With that context set, you should define resilience in enterprise language. Resilience is the ability of the organization to continue delivering critical outcomes despite failures, attacks, mistakes, and unexpected demand. It is not only a technology attribute. It includes operating models, decision rights, incident processes, and skills. A resilient enterprise architecture ensures that critical services have clear availability goals, that recovery plans are realistic, that visibility exists to detect problems early, and that support teams can act quickly without confusion. With resilience defined, you begin with availability because availability is what customers and executives feel first. Availability is the ability to keep a service usable when components fail or demand spikes. Your role is to set realistic availability expectations based on business criticality and to ensure the architecture design supports those expectations. The most important leadership conversation is trade-offs. Higher availability usually requires more investment, more discipline, and more operational maturity. A strong architect makes availability a deliberate choice, not an assumed promise. With availability framed, you now anchor resilience decisions in business criticality. If you treat every service as equally critical, you will overspend, over-engineer, and still miss the real priorities. You define critical services by business impact, customer harm, financial loss, safety implications, regulatory breach, and reputational damage. Then you align resilience investment to those priorities. This is how you keep resilience fundable and defensible, because leaders can see why some services require higher investment, while others can accept simpler approaches. With criticality understood, you now design with failure modes in mind. Failure modes are the ways your system can break, such as dependency outages, capacity saturation, data corruption, misconfiguration, identity compromise, and integration failures. Many organizations only discover failure modes during incidents, which is the most expensive time to learn. As an enterprise architect, you make failure modes visible early so that containment, recovery, and fallback behaviors become part of the design intent, not a late addition. With failure modes visible, you now address disaster recovery because recovery is where leadership confidence is earned or lost. Disaster recovery is not simply having backups. Disaster recovery is the ability to restore critical services within an agreed time and with an agreed level of data loss tolerance. Your job is to translate business tolerance into architecture requirements and to ensure recovery plans are realistic, tested, and operationally owned. If disaster recovery is not owned and rehearsed, it becomes an illusion that disappears when needed most. With disaster recovery positioned correctly, you now make the key trade-off explicit. Recovery time is how quickly the service must be restored. Recovery point is how much data loss is acceptable. These are business decisions with cost implications, not technical preferences. When leaders approve recovery objectives knowingly, they are choosing a balance between investment and risk. Your role is to present the consequences clearly. So leadership understands that tighter recovery objectives often require stronger architecture patterns, higher operational discipline, and higher ongoing cost. With recovery objectives clear, you now address dependency resilience because modern systems are ecosystems of dependencies. You design a service to be resilient not only to its own failures, but also to failures in identity services, network services, data stores, third-party providers, and upstream systems. This is where architecture patterns matter because resilience often comes from consistent dependency management. Clear timeouts, safe retries, graceful degradation, and isolation of failures. So, one dependency outage does not collapse the entire service. With dependencies in focus, you now design for graceful degradation. Graceful degradation means the system continues delivering the most critical functions even when some components are degraded or unavailable. This concept is leadership relevant because it protects customer trust during disruptions. Instead of total failure, you design partial service that prioritizes essential outcomes. The organization may accept that some features are temporarily unavailable if core functions remain stable and recovery is underway. This is resilience in business terms, protecting what matters most first. With resilience behaviors defined, you now move to observability because resilience without visibility is guesswork. Observability is your ability to understand what is happening inside a system through the signals it produces. This includes operational health, performance characteristics, dependency behavior, and security relevant events. As an enterprise architect, you make observability a non-negotiable design requirement for critical services. Because detection speed and diagnostic clarity determine how long incidents last and how much business harm occurs. With observability framed, you now focus on the signals that matter most to leaders and operators. Health signals show whether the service is functioning. Performance signals show whether users are experiencing slowdowns and failures. Business impact signals show whether customer journeys are failing, transactions are being delayed, or revenue is being affected. When you align observability to business impact, you enable executives to make informed decisions during incidents, such as when to invoke recovery measures, when to communicate to customers, and when to prioritize stabilization over feature delivery. With observability established, you now address supportability because resilience fails when support models are unclear. Supportability means ownership is clear, escalation pathways exist, runbooks are practical, and teams can respond under pressure without improvisation. It also means the solution design does not require constant heroics or rare expertise to operate. A supportable architecture anticipates operational reality, including staff turnover, handover to business as usual teams, and the need for repeatable response processes rather than tribal knowledge. With supportability in mind, you now treat operational readiness as a design requirement rather than a project milestone. Operational readiness means monitoring is active, alerts are meaningful, incident response is rehearsed, access pathways are controlled, and recovery procedures are understood. When operational readiness is weak, go live becomes a gamble. When operational readiness is strong, go live becomes a controlled event. This is where architects build long-term trust because a stable go live protects leadership confidence and reduces operational disruption. With operational readiness established, you now embed resilience into governance so it does not depend on individual discipline. You define resilience expectations as part of architecture standards, assurance checkpoints, and decision records. You also define how exceptions are handled, how residual risk is accepted, and how resilience metrics are reported over time. When resilience is governed, it becomes repeatable across portfolios. When it is not governed, it becomes inconsistent and fragile, and critical services end up relying on luck rather than design. With governance in place, you now handle the executive question: why spend on resilience when nothing is currently broken? You make the case by connecting resilience investment to avoided harm, such as reduced outage cost, reduced regulatory exposure, reduced incident recovery time, improve customer trust, and improve staff sustainability through reduced on-call fatigue. You also show that resilience reduces long-term cost by preventing repeated emergency fixes and by improving stability, which increases delivery velocity over time. This is how you turn resilience from insurance into strategic capability. With the investment narrative clear, you can now ground resilience in a scenario leaders recognize. Imagine a customer services platform during a peak billing period when usage is high and customer expectations are strict. A dependency failure occurs in a downstream billing service. A resilient architecture isolates that failure, degrades gracefully by maintaining critical customer functions, and triggers clear monitoring signals that show business impact immediately. Support teams follow defined escalation pathways. Leaders understand whether recovery objectives are at risk, and disaster recovery decisions are made confidently if needed. The outcome is controlled disruption rather than public failure. With the scenario in mind, you now recognize why resilience often fails in real organizations. Resilience fails when availability targets are assumed, when recovery objectives are undefined, when dependencies are ignored, when observability is incomplete, and when operational readiness is treated as someone else's job. It also fails when resilience is unfunded and ungoverned, causing critical services to rely on heroic response rather than predictable design. You avoid these failures by treating resilience as architecture quality, operational discipline, and governance obligation. Let's now discuss the key takeaways from what you learned so far, so you can design resilient enterprise architecture that leaders can fund and operations can sustain. Resilience is the ability to maintain critical outcomes through failure, and it is achieved through deliberate availability decisions, realistic disaster recovery objectives, dependency resilience, graceful degradation, strong observability aligned to business impact, and supportable operating models. When resilience expectations are governed, measured, and funded, you reduce outage harm, improve recovery confidence, and protect customer trust while increasing long-term delivery velocity. As you move into the next lecture, start asking one leadership question about every architecture decision. What happens when this fails? And how quickly can you recover without chaos? Subscribe to the channel so you do not miss the next videos in this playlist, like this video, so it reaches more leaders and architects. Comment with the resilience challenge you face most often, and share it with someone responsible for service ownership, incident response, or transformation governance.